Pluto is a faraway, elusive, and less conspicuous planet that was once considered part of our solar system. However, recent groundbreaking statements from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have brought Pluto back into public discussion. They have proposed that this icy planet might be heading toward a potential collision course with Neptune. But how can such a scenario be possible, and what would the consequences be of such a monumental event? Are we witnessing an unusual, unpredictable phenomenon, or is there something more to this impending cosmic disaster? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto, which was once classified as a planet but later redefined as a dwarf planet, continues to be a subject of fascination and study within the vast universe. Recent speculations from leading experts have suggested that Pluto's orbit is alarmingly close to Neptune's, prompting astrophysicists Neil deGrasse Tyson and Michio Kaku to warn of the possibility of a catastrophic encounter between these two celestial bodies, one that could pose a significant risk to Earth. But how could such a collision even occur? Pluto's orbit. Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes a staggering 248 years to complete one full orbit, and since its discovery in 1930, Pluto hasn't even finished a single full revolution. However, the intrigue doesn't end there. Pluto's orbit is characterized by its distinctly elliptical shape, straying far from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is its tilt. It is inclined at an angle of 17 degrees to the plane of the solar system. This gives Pluto's path a far more erratic trajectory compared to the more orderly orbits of the other planets, adding complexity to its orbital dynamics. Perhaps one of the most fascinating aspects of Pluto's orbit is that it intersects with Neptune's. For roughly 20 years during each orbit, Pluto actually travels closer to the Sun than Neptune does, defying conventional expectations of their relative positions in the solar system. This raises an obvious question. Why hasn't Pluto collided with Neptune? Why Pluto hasn't collided with Neptune? The answer lies in the gravitational forces exerted by other planets. After Pluto's discovery, astronomers quickly set out to understand its strange orbital behavior. Unlike the other planets, whose orbits are relatively close to the solar plane, Pluto's orbit stands out due to its steep inclination and highly irregular shape. The puzzle deepened when it became clear that Pluto's orbit intersects Neptune's. Despite this, Pluto's orbit remains stable, demonstrating the intricate dynamics of celestial mechanics, or the so-called three-body problem in space. Understanding how three objects, like Pluto, Neptune, and the Sun, interact gravitationally is key to this scenario. It's like trying to predict where these objects will be based on where they started and how they influence one another. The stability of orbits. The stability of all planetary orbits is ensured by the concept of non-concurrent libration. In the case of Pluto and Neptune, this means that whenever Pluto crosses Neptune's orbit, the two bodies are always positioned at least 90 degrees apart. This spatial separation prevents a collision. Another contributing factor is orbital precession, which refers to the slow movement of a planet's orbit. For Pluto, this means that when it comes closest to Neptune, or any giant planet, it is positioned well above their orbital plane, providing another layer of defense against potential collisions. An additional factor at play is VSK wobbling, a concept named after three researchers, V. Sidlichovsky, S. Farasmello, and J. Kovalevsky, who studied how celestial bodies interact with one another's gravitational pull. This wobbling effect explains why Pluto's orbit, though seemingly chaotic, remains stable over long periods. The gravitational tugging between Pluto, Neptune, and the Sun influences Pluto's orbit, ensuring it remains relatively smooth despite its irregular shape. VSK wobbling shows that even in the most unpredictable environments, there are underlying patterns and forces that maintain stability. This three-body problem is crucial to understanding Pluto's orbit, its relationship with Neptune, and the behavior of distant objects in our solar system. Simulations and long-term predictions. Numerical simulations conducted in the late 1980s revealed that Pluto's orbit, despite the stabilizing forces at play, is actually quite erratic. Small deviations in its initial conditions could lead to significant differences in its path over centuries. Nevertheless, these simulations also showed that Pluto's orbit maintains stability over incredibly long timescales, such as millions or even billions of years. To fully grasp the dynamics between Pluto and Neptune, it is important to consider the gravitational influence of the giant outer planets like Neptune, Jupiter, and Saturn. Neptune's influence. It governs Pluto's orbit in a 2:3 resonance. For every 2 orbits Pluto completes around the Sun, Neptune completes 3. This resonance keeps Pluto's orbit stable. Jupiter's gravity. As the largest planet in the solar system, Jupiter's gravity further stabilizes Pluto's path. Saturn's influence. Saturn also contributes to this delicate dynamic. Without these stabilizing forces, the solar system would be far more chaotic, with planets potentially colliding or being ejected from their orbits, triggering catastrophic consequences. The possibility of a collision. The possibility of Pluto colliding with Neptune in the future highlights the complexity of celestial mechanics. Even though Pluto's orbit may appear chaotic, it is actually a testament to the delicate balance of forces that keep it in place. Astrophysicists like Neil deGrasse Tyson remain skeptical about the likelihood of a Pluto-Neptune collision. Tyson, a key figure in Pluto's reclassification from a planet to a dwarf planet, has offered valuable insights into Pluto's future. While Tyson acknowledges the complexities of planetary orbits, he does not believe that Pluto is on a direct collision course with Neptune. Instead, he sees these discussions as a reflection of how much more there is to learn about celestial mechanics. Will Pluto collide with Neptune, or is this merely a misunderstanding of orbital dynamics? Only time and further research will provide the answers. Final thoughts and what's next? A collision between Pluto and Neptune would not only have major implications for our understanding of planetary behavior, but could also provide valuable insights into the evolution of the solar system itself. Future research will focus on refining models of Pluto's orbit using advanced simulations, studying the gravitational influence of other celestial bodies, including the hypothetical Planet 9, which some believe could alter Pluto's. While current models suggest that Pluto's orbit remains stable for millions of years, minor perturbations from external forces could push it onto a new trajectory, one that defies the delicate balance it currently maintains with Neptune. But what kind of force could disrupt this finely tuned celestial dance? The influence of a hidden celestial body. Recent discussions among astrophysicists have revived the Planet 9 hypothesis, a theoretical, unseen planet lurking in the outer solar system. If such a massive body exists beyond Neptune, its gravitational influence could gradually alter Pluto's orbit. Scientists estimate that if Planet 9 is real, it could be 5 to 10 times the mass of Earth, exerting enough pull to shift the orbits of small icy bodies in the Kuiper Belt, including Pluto. Over time, a subtle yet persistent force from Planet 9 could push Pluto closer to Neptune, increasing the risk of a catastrophic encounter. However, Planet 9 isn't the only wild card in this equation. A wandering star, a disaster waiting to happen? Beyond our solar system, the universe is filled with rogue stars, distant suns that drift through interstellar space. Occasionally, one of these stars passes close enough to disrupt the gravitational harmony of our solar system. If such a star were to pass within a few light years, its gravitational pull could slightly nudge Neptune's orbit, causing a ripple effect. This small shift might be enough to throw Pluto's orbit into chaos, altering its resonance with Neptune and making a collision far more likely. Historical records suggest that similar events have happened before. Some astronomers believe that a passing star may have disturbed the orbits of outer solar system objects millions of years ago, possibly sending comets hurtling toward the inner planets. Could Pluto be next? The day Pluto and Neptune cross paths. If, against all odds, Pluto and Neptune were to collide, the results would be catastrophic. 1. The initial impact. As Pluto enters Neptune's gravitational well, it would experience intense tidal forces, causing fractures across its icy surface. If the collision were direct, Pluto would be completely obliterated, sending frozen debris scattering across the solar system. Neptune, being a massive gas giant, might absorb most of the impact, but its atmosphere could be violently disturbed, creating massive storms that could rage for centuries. 2. The aftermath. The debris from Pluto's destruction could form a temporary ring system around Neptune, much like Saturn's. Some fragments might be ejected into deep space, while others could be drawn toward Neptune's core, altering its chemical composition. If any large chunks of Pluto's remains were thrown toward the inner solar system, they could become deadly meteorites, potentially colliding with Earth or Mars. But what if the collision was only a near miss? A cosmic close call. Pluto's new fate. If Pluto were to graze past Neptune rather than collide head-on, its orbit could be dramatically altered. Ejection from the solar system. If Neptune's gravity slingshots Pluto with enough force, Pluto could become a rogue planet, doomed to drift endlessly through the cold, dark void of interstellar space. A new moon of Neptune? Pluto might instead be captured by Neptune's gravity, joining its system as a new, erratic moon. A destructive chain reaction. A near miss could destabilize other objects in the Kuiper belt, causing a domino effect that sends comets and asteroids tumbling toward the inner solar system. What lies ahead? While a Pluto-Neptune collision remains unlikely in the near future, the chaotic nature of celestial mechanics means nothing is ever truly certain. Scientists continue to refine their simulations, searching for answers hidden within the vast expanse of space. As telescopes grow more powerful and computational models more advanced, we may one day uncover the ultimate fate of Pluto. Will it continue its stable, frozen dance with Neptune for millions of years? Or will a small cosmic disturbance send it crashing into history? Only time will tell. Pluto's survival, a new destiny in the cosmos. Despite the looming threats of gravitational shifts and cosmic disturbances, Pluto's fate may not be sealed in destruction. There exists another possibility, one where Pluto escapes catastrophe but undergoes a radical transformation, changing its place in the solar system forever. If a gravitational disturbance disrupts Pluto's current orbit without leading to a direct collision, several extraordinary outcomes could unfold. Scenario 1. Pluto becomes an inner solar system wanderer. One of the most dramatic possibilities is that Pluto is pulled inward, migrating toward the inner solar system. If Neptune's gravity flings Pluto toward the Sun, its icy surface would begin to melt, unleashing a series of stunning changes. Atmospheric expansion. As Pluto absorbs more sunlight, its thin nitrogen-rich atmosphere could expand dramatically, resembling the thick hazes of Titan, Saturn's moon. Surface transformation. The frozen plains of Pluto would thaw, revealing new geological features. Subsurface oceans, once hidden beneath thick layers of ice, could become more active, sparking speculation about potential alien life. A new mini-planet? Instead of being a frozen dwarf on the solar system's edge, Pluto could take up a new position, perhaps orbiting Mars or even Earth as a second moon. However, such a journey would not be without danger. If Pluto strayed too close to Jupiter, it could be shattered by tidal forces, or worse, consumed by the Sun as it spiraled inward. Scenario 2. Pluto becomes a captured moon of Neptune. If Pluto avoids total destruction but fails to escape Neptune's gravity, it could become Neptune's newest moon. This would make it the largest and most distant moon in Neptune's system, joining Triton, which is already believed to be a captured Kuiper belt object. A new sibling for Triton, Pluto and Triton could engage in a gravitational tug-of-war, influencing each other's orbits in ways scientists have yet to predict. Volcanic awakening. If captured, Pluto's internal structure could be reshaped by Neptune's gravitational pull, triggering cryovolcanism, volcanoes that spew ice.